This is the final part of my AI Trust and Reliability series. Across this series, I talked about control layers, validation before action, traceability and replay, human review, and runtime governance. Now, I want to bring all of that together. The main point is simple: reliable AI is not just a model quality problem, it is a product design problem. Because in production, the question is not only did the model generate a good output? The real question is what does the system do after that output is generated? That is where AI product management becomes important. A model can generate a useful answer, and the product can still fail if the system does the wrong thing next. Most AI product discussions still start with the model. Which model should we use? How accurate is it? How good is the prompt? How well does it perform in evaluation? Those questions matter, but they are not enough. A demo can focus on output quality, production cannot. Once AI output can update a ticket, route a case, assign severity, send a response, call an API, approve a workflow, or influence a business decision, the output is no longer just content. It becomes part of execution, and execution needs product design. That is why reliable AI is not created by the model alone. It is created by the system around the model: control layer, validation, human review, traceability, runtime governance. These are not optional extras. They are the operating layers that make AI usable in real workflows. This is the product question that matters. Do not ask only, can the model do this? That is a model question. The better question is, should the system allow this automatically? That is a product question. There is a big difference. A model may be accurate enough to generate a useful response, but should that response auto execute? What is the cost if it is wrong? Can a bad output be reversed? Who reviews high risk outputs? What gets logged? What happens if the system is uncertain? That is where AIPM work becomes real. The AIPM's job is not just to manage model output. The job is to design what happens after model output. If the output stays as a suggestion, the risk may be low. But if the output triggers a workflow, updates data, changes customer experience, or calls an API, the risk changes. That boundary has to be designed, not assumed. This slide is one of the most practical parts of the framework. Every AI capability needs an automation boundary. In simple terms, what authority does the AI have? Can it only suggest something? Can it decide between predefined options? Can it trigger a downstream workflow? Can it update data or system state? Can it route something to human review? Can it block execution entirely? These are very different levels of authority. A suggestion is usually lower risk. An automatic update or API triggering action carries much higher risk. A block or escalation may be necessary when policy or safety boundaries are crossed. This is where product judgment matters. Do not let the system drift into full automation just because the demo worked well. Define what the AI can suggest, decide, trigger, update, review, and block. As authority increases, control should increase with it. That is how you avoid turning a useful AI feature into an uncontrolled production risk. This is the reliability stack. Reliable AI needs more than output quality. It needs control, validation, review, traceability, and runtime governance working together. The control layer defines what the AI is allowed to do. Validation checks the output before it triggers action. Human review brings judgment into the workflow when risk is high or context is uncertain. Traceability gives the team a full record of what happened. Runtime governance makes sure the rules and controls are active while the system is actually running. Each layer matters. If you only have a model, you have output. If you add these layers, you start building a production system. That is the difference. A reliable AI system is not just a model, it is the model plus the operating system around it. Control, validation, review, traceability, governance. This is how AI moves from demo behavior to reliable system behavior. Accuracy matters, but accuracy alone does not tell you whether an AI system is safe, scalable, or production ready. A model can score well and still create a production mess. Accuracy tells you whether the model performed. These metrics tell you whether the product is operating safely. Automation rate tells you how much work is moving without human touch. Validation failure rate tells you how often output fail checks. Human review rate tells you how often judgment is needed. Escalation rate shows how often cases need senior or policy review. Block rate tells you how often the system stops execution. Override rate tells you how often human reverse automated decisions. Audit completeness tells you whether decisions have a full traceable record. Replay success tells you whether decisions can be reproduced later. These are not vanity metrics, they are product signals. They show whether the AI system is operating safely and efficiently. They also show where the system needs improvement. Maybe too many low risk cases are going to review. Maybe high risk cases are not escalating fast enough. Maybe humans keeps overriding the same type of model output. Maybe audit records are incomplete. That is product signal. That is how AI systems mature, not by launching once and hoping for the best, but by observing behavior, learning from exceptions, and improving the operating model. This is the final takeaway of the series. Do not manage AI only as a model, manage it as a production system. That is the whole message of this series. This means designing what happens after model output. It means defining the automation boundary. It means validating before action. It means keeping a traceable decision record. It means making governance active during execution. And it means measuring the system, not just a model. A demo can stop at a good answer. A production system cannot. A production system has to ask what happens next. Can we trust it? Can we explain it? Can we reverse it? Can we govern it? Can we improve it over time? That is the AI PM's role. Not just prompt engineering, not just model selection, not just feature shipping. The AI PM's job is to design the product system and operating model that makes AI reliable enough to use in real workflows. That is how we move from model output to reliable system behavior. Design, control, govern, trust. Reliable AI is not created by the model alone. It is created by the system around the model. And designing that system is one of the most important jobs for AI product managers. This closes my AI Trust and Reliability series. In the next series, I will go deeper into practical AI product management design frameworks.